Thanks everybody for joining this British Society for Geomorphology lunchtime seminar. Today's talk is by Dr Nigel Pontee, who'll be presenting on the morphological evolution of the Steart Marshes habitat restoration scheme. Nigel, your window is just poking into the presentation bit. There we go. So the talk will be recorded for those that want to listen back in due course or share the material, and be on the BSG's YouTube site in due course. If you can all make sure that your microphones are muted and cameras are off, just to avoid disturbance for the presentation. There'll be a question and answer session afterwards, and you can unmute your mic, put your hand up, unmute mic, and I can chair that discussion. The next talk that we have actually is next week. We have two presentations in this month. So the next talk is next Wednesday with Martin McGelly, who's going to be presenting a talk on landslides as geosystem services. So look out for that presentation. But on that, I will wrap up and pass over to you, Nigel. Thank you.
Well, thank you very much, Paul, and thanks for the opportunity to speak to all of you in your lunchtime today. It's nice to be here. So the main part of this talk is on the morphological evolution of the Steart Marshes habitat restoration scheme. It celebrated its 10th birthday last year, so it was a sort of good time to review some of the thoughts that went into the design of that project, and then some of the changes that have occurred since it opened and was subject to tidal conditions. But before I get started on that, I'd been asked to sort of explain a little bit about my background and my route into consultancy as an industry. And so I've put together a few slides on that, just to illustrate really a potential route into consultancy, and we're happy to take questions on both the main topic of the Steart Marshes and also career, if that's of interest. So let's get started. My route into consultancy. Time flies by, and the older you get, the quicker it goes by. But I guess my career started in 1990 with a BSc in geological oceanography back in Bangor in North Wales. They had the Prince Madoc research vessel then. I actually thought it was best to go to that university rather than Southampton because they had the research vessel, and then about 5 years later Southampton became the National Oceanography Centre and gained a much bigger ship. But anyway, I had a great time in Bangor, as I guess most people do at university. A lot of work on coastal processes and sedimentary environments in that first degree. I guess at that time I was thinking, I'm going to do this degree, I'm going to learn about sedimentary environments, and then I'm going to go work for an oil industry, someone like Shell doing oil exploration. That was sort of my thoughts as I entered into that degree. Was I going to go for Shell or another oil company? I guess after doing my degree, I still was undecided, and I went off to Reading University to do an MSc in sedimentology. I was still really interested in working for an oil company, and this degree had a lot of stuff on sedimentary environments and processes, but also on soft rock geology, and I was still thinking I was interested in an oil company sort of position, and I got funding from a consortium of oil companies as an extra bursary, which was helpful. And then during the course of the degree, I decided I really rather preferred coastal processes, and so off I went to the Humber estuary to make measurements of coastal processes on a salt marsh, a place called Welwick on the north bank of the Humber. That's now a managed realignment site. After that, I decided I would carry on in coastal processes. I was still, I was still umming for a while whether I would join a big oil company or would I start to work for a company such as HR Wallingford. I'd met someone from HR Wallingford who'd come to give us some talks, and I thought that sounds really interesting, all that coastal engineering, but isn't it a shame I'm a geomorphologist, I shall never get a job in coastal consultancy. But anyway, I eventually did, and I shall see. So I stuck with coastal processes. After my master's, I went on to do a PhD on mixed sand and gravel beaches on the Suffolk coast with Ken Pye, also at Reading. And there was some reasoning for picking the Suffolk coast deliberately, because at the time it was going to be the location for the next Sizewell nuclear power station, and that then did in fact get built. So there was a lot of coastal process interest, and now Sizewell's earmarked for a new nuclear build program. So still an area of coast with lots of interest. And anyway, I really enjoyed working on these different beaches. I picked 3 of them across the region, and then analysed how they responded to wave conditions over time. After that, I was lucky enough to get a nicely funded position as a postdoc in Bordeaux. It was funded under the European Union programme of research called Human Capital and Mobility, and off I went to Bordeaux for 18 months, and we had a series of samples in salt marshes, and we took some more sediment samples and did some analysis on the sand dune system, which covers the Medoc Peninsula in southwest France, and the big dune de Pilat on the coast. You can see in the top right from this a little bit grainy scan of a postcard. It was the largest coastal dune in Europe, 120 meters. We did some dating on that with optical thermoluminescence techniques to date the sand in the coastal system, calibrate it against some radiocarbon dates, and then date some of the dunes further inland. And that was pretty cool work. It overturned the conventional thinking on the chronology of dune development across the peninsula. That was interesting. And this is the vineyards in the area, but there's lots of different geologies, and that gives rise to the different soils, and that gives rise to the different appellations of wine. Sadly, at the time, I was only interested in beer, but I also did some work on the salt marsh, 2 generations of salt marshes along the Gironde estuary, and course through those marshes, which was interesting. Then eventually I moved into consultancy after that, something like 1996, I think. Firstly to a company in Southampton, now known as ABP Mer, and then later into Halcro, which became CH2, which became Jacobs. So Jacobs is quite a big company, 45,000 staff. It's not the biggest engineering consultancy, but it's fairly sizable, and we cover all sorts of engineering and science type subjects. My job at Jacobs, I do mainly project work, so clients are paying us to do work, and I also have a global role to help us win work and deliver it and recruit staff around the world. I tend to get involved in projects, in international working groups, best practice guidance for beach management and such like, and I have a visiting professorship at Southampton. I sit in the Ports and Maritime team. We do all sorts of coastal work. Here's just a smattering of that. We do strategic planning studies, we do construction of defences, we do blue carbon work, we do working with nature or nature-based solutions, we do habitat creation. I'll move us on so we spend more time talking about the project. But yeah, I'm now working in a consultancy company, despite my misgivings that they only ever employed engineers. Actually, they do employ coastal geomorphologists, and that's a useful skill set. Lots of my work has been on habitat creation, restoring coastal floodplains back to salt marshes. This is one such project, the Steart Marshes area in Somerset. This is an image of the site looking sort of up into the Bristol Channel in the hazy distance. This is the Parrot Estuary, and I'll show you a few more slides in a minute of exactly the orientation of the site. But the site is in the foreground here with that big lagoon of water in the channel system. I'll give you a bit of a background to the study site, look at some of the things that we put some thought into designing on this area, and then look at the evolution of it, wrap up with some of the lessons learned and the conclusions. So the study background, here we are, we're in the Bridgewater Bay area. The Steart Peninsula is this peninsula of land between the Parrot Estuary here and Bridgewater Bay here. Bridgewater Bay is in the Bristol Channel before the Bristol Channel narrows and becomes the Severn Estuary. And this is our study area here on the Steart Peninsula. And this is the scheme, the project that we developed. The project was undertaken to provide compensatory habitat. So it was believed that habitat was being lost due to sea level rise and the presence of flood defences in the Severn Estuary. And the Environment Agency were charged with the responsibility of compensating for that habitat loss. And so this was one of the sites that was chosen to compensate for that loss. The project took quite a long time from its very first glimmerings of a project back in 1998. It took nearly 16 years before the site was opened. So there was pre-feasibility reports back in 1998. Then there was a vision statement in 2002. Then there was an advisory group set up, and then design work started in 2009, and the site then opened some 5 years later. So some of the projects like this can take a while from initial ideas and discussions with landowners and local stakeholders through to the opening of the scheme. And the design work is usually about a couple of years, 2 years, and then there's a couple of years of construction. So the project's led by the Environment Agency. They employed well, we were Halcro then, we became CH2, and we're today Jacobs as the designers for the project. We were working with the team Van Ord, who are the contractors. They're the guys with the machinery and the skills to build what we design. And WWT, Wildfowl and Wetland Trust, came on board early in the design stages. They were the after a process of competitive tendering, WWT were selected to be the site managers. And it's good to involve the site managers in the design of the scheme, so they get something that they can work with and they're happy with. So we had a big team of people, and we had about 4 or 5 years worth of work to design this, followed by some monitoring. So here's, let's show you about the design. So here's the peninsula, and the area sort of divides up by, there's a road running sort of north-south here, Steart Drove, and then some high voltage power lines running this way, and that sort of chops the area up into some compartments. And there's 3 compartments make up the Steart Marshes scheme. There's this managed realignment scheme here where the water comes in and out through a free opening. There's to the south of the power lines, there's a regulated tidal exchange where tidal waters come in and out but through a structure, and then there's a freshwater area here. And this area was going to be developed by the Port of Bristol as another wetland creation site for compensation for their own needs. That sort of went on hold back in 2000 and where were we, about 2010. There was talk of it. It went on hold because the port didn't need it. It's now being designed as we speak. Anyway, the blue area is the area of our scheme, Steart Steart Marshes. When we were working on this whole project for the Environment Agency, the project was called the Steart Coastal Management Project. When the scheme opened and WWT started to manage the site, they renamed it as one of their reserves, the Steart Marshes Reserve. So let's just tell you a little bit more about some of these areas. Here's our freshwater area. Here's Steart Drove. And basically we have to do some redirecting of some of the streams that come into the area and build some new flood embankments. We did some habitat enhancements, some scrapes to lower areas and create areas of standing water. For that one, for the regulated tidal exchange, we did some, here was an existing sluice which allowed the freshwater to drain off the site into the estuary, and we took the flap off that sluice to allow tidal waters in. We built some new embankments, these green lines around the rear of the site. We did some modifications to bed levels to create some scrapes or low areas where water would stand and be suitable for bird usage. And we diverted one of the stream, South Brook. Instead of flowing through the site, it comes around the outside before joining back into the drainage system just before it goes into the estuary. And one of the biggest areas, which is the focus of this talk, was the intertidal habitat area created in the managed realignment. So here we've created a breach, and I'll show you some photos of the design of that and how it evolved. And we created creek system, we created some lagoons up here, which I'll show you in a minute, created some new flood embankments here, so the tidal waters come into this area and they're constrained by the new flood embankments, and there's higher land here. Steart Village is here, and then there's a road around the rear. And then Bristol Channel is off to the north, and Parrot Estuary is here. So that's an overview of the scheme, and if we sort of dive in, I'll tell you a bit more about how we designed it. Right at the beginning of the project, we were wondering how to get water into our areas, either from the River Parrot or from the Bristol Channel. We considered various options. I mean, options to the Bristol Channel meant that either you had to have a tidal causeway or you had to have a bridge. And the bridge was expensive. The tidal causeway would have limited people's access and potentially would have had quite high maintenance costs to maintain the road. So what we ended up with was taking the water into our scheme from the Parrot Estuary. Because the site is a large area near the mouth of the estuary, we knew from experience in other estuaries that when you recreate additional intertidal habitat near the mouth of the estuary, you could raise water levels. So a necessity for this particular project, it was a large project, we had to do some numerical modelling of water movements to evaluate the effect of the site. And we found that several of the options raised water levels in the estuary, and that was a really big influence on picking a design which led to the smallest increases in water level. So we tried designs with lots of openings because they would look like a natural marsh, but those allow this area to fill really rapidly, and the consequence of that is some of the water that comes into the estuary comes into our site, yes, but some of it carries on up the estuary and increases water levels. So having done quite a lot of modelling, we opted for a single breach orientation somewhere around, I think it's here, is the final breach location, and we didn't breach the existing flood walls anywhere else, and that minimised the water level increases in the estuary. And there's a paper on that if you're particularly interested, with a bit more explanation. So we spent a lot of time modelling. We needed to design a breach, an opening in the existing flood embankment to allow water to come in. And what we realised was, from experience at other sites, That breach obviously concentrates the flow of water in and out of the site, and that leads to erosion. And here's an image on the top left from a managed realignment site in the Humber estuary. This is something like 5 days after the site is opened, and this is looking out from the former flood embankment, looking out into the estuary, and here you see this channel that's eroding away. That channel started off as 1 metre wide and 1 metre deep, at the same level of as the green salt marsh surface, and over a period of 5 days, the force of the water running in and out creates this huge sort of canyon. And we knew that was going to happen. It could be quite alarming for stakeholders to come and see that sort of process going on, and they think it's all going wrong. So we spent a lot of time modelling how big an opening to create and assessing how big it would get. We used numerical models looking at the speed of the flow and the critical flows needed to erode sediment, and then we tried to design a breach that was big enough that it wouldn't erode that much. We did some other techniques as well, using regime analysis to predict stable breach dimensions, and I'll show you a bit more about those and how well they worked later on. Salt marshes have lots of creeks, lots of channels on them. They carry the water in and out of the site. They allow it to drain fully. They're good for vegetation development. They're good for fish usage and bird usage. So we spent quite a bit of time designing creeks within our site. Some managed realignment sites still retain their remnant creeks if they've only been reclaimed, say, 50 years ago. But Steart Marshes was reclaimed probably as early as Romano-British times, so between the 1st and I think 3rd century AD. So any former creek channels are long gone, and the site's been farmed heavily, so no creek systems. So we need to make some creek systems and excavate some. So we iterated, we avoided some environmental constraints and some archaeological constraints, and we constructed a creek system. It started off quite complicated. You can see these red lines here, and that looks, I quite like that one because that was a natural looking creek system. But we, the future site managers wanted to graze the site, and they were concerned that such a complicated channel system would lead to cattle straying into the creeks and drowning, especially on flood tides. So they wanted a simpler creek system, which is why we've got this herringbone system. A key thing of designing the creek system ultimately was balancing the volumes of material that we excavate from the creek with the amount of material we need to build these new embankments. And we want to, there's various sort of iterations needed, because we don't want to have to export material off site because that's expensive, and we don't want to import material onto the site because that's expensive as well. So we want to work with the material we've got, so that we made sure that the excavated volumes of sediment match the volumes we need. Cut and fill balance in engineering terms. We made some lagoons. These two pools at the top, these ones here and this one, if you can see my cursor, those are some sort of shallow lagoons. They were good for two reasons. One, they could give us a ready supply of material to build these new embankments, which you can see around the rear. And also they provided some valuable habitat for birds and a visitor facility when there's some viewing hides are on this rear wall. People can come see the tide coming in and out these features, see the birds using them, as opposed to walking all the way around the site to get to the entrance, which is interesting, but it's a long way, so not everyone can do that. So there's an interest feature at the back of the site, and they had some water control structures built onto them to allow water levels to be adjusted. And this is just a note really to remind me that the area is very flat. Prior to us undertaking the project, all of this area is crisscrossed with freshwater drainage channels, and that required quite a bit of detailed consideration to allow all of that fresh water to continue to drain off this area when we've flooded it with tidal water. So all of those drainage channels are sort of captured and rerouted. There's various structures. There's over 100 water control structures, extensive modelling done to make sure this area can continue to drain and that we're not causing extra flood risk by filling this area with tidal water and then having backups of fresh water into other areas. Okay, so I wanted to tell you how the site has evolved. Here's a LiDAR difference plot. This one is going from, I think, November 2014. So the site was opened in September. So this is just shortly after the site was opened until September 2020. So about 6 years. That was the latest LiDAR. It's a difference plot. The green is where the elevations have increased. The red is where they've eroded. So 4 things to point out on this, really. The biggest area of change in the 3 compartments is within the tidal area. It's getting water in and out of it on an almost daily basis, and it's increasing in elevation, and that's mainly down to the sediment that's growing in the area. There's some erosion. I'll tell you a bit more about that later. In the 2 other compartments, the regulated tidal exchange compartment and the freshwater compartment, much smaller changes. We're not seeing these big bed level changes. We're seeing a slight bit of change due to probably vegetation growth. And then the final thing really is to point out that around the main channel of the estuary, it's very dynamic. It's a very high tidal range. It's nearly 10 meters at the mouth of the estuary. So that leads to strong tidal currents. It also leads to the creation of a low water channel in the estuary, and that meanders around sort of left and right. And that causes erosion and accretion over time. So the estuary itself is very dynamic. And I'll show you some of the detail of some of these changes now. So an area of really big change is the breach. We create a big opening to allow the tide to come in and out. So this is looking into the site. Before it was opened, you can see our channel system's constructed. It's full of water, but it's full of rainwater. It was one of the wettest winters on record when the site was being built. So here's the site. It's full of rainwater. Here's the flood embankment that's going to be breached, and you probably can't. You might just about be able to see there's some new embankments right around the back, and we're going to eventually breach this area here. But that did happen, but prior to that happening, the contractor allowed this fresh water to drain out through this existing channel here. To get rid of the water, and 2, to sort of get some of the erosion out of the way, so there was less erosion when the site opened. What that meant was this channel then deepened, and when there was a small cut made through here, the tidal waters occupied this former channel, and that sort of became a template. And here's that erosion taking place. And I've got some more slides for that. So the tide's now flowing in and out of this channel, and it's rapidly eroding this area here, just like that example you saw in the Humber estuary. This is what it looks like on the ground. So this is cutting down by several meters over a matter of weeks. You can see the slump blocks falling in down here. These are toppling in. There's big tension cracks here and some rotational slumps going on here due to the rapid down cutting of that channel. So it's really quite dramatic. And we spent quite a bit of time monitoring the site to see the speed at this erosion. And we made some assessments during the project. Let's just see what I've got next. Right, okay. We made some assessments at the outset the project of how quick this erosion could be, because it creates sediment. Sediment gets carried into the estuary, and that could potentially be detrimental to other estuary users or habitats. We made some estimates. What we basically found was that it eroded much more rapidly than we thought. I estimated that it might take 4 years before an equilibrium channel was developed. In fact, it took about 7 months. And we plotted the graph down the bottom is the rates of erosion over time. And we could see that after about 7 months, the exit channel, which we're looking at here, began to show phases of erosion and accretion. So up to then, it was just eroding. Then it stabilized and began to fill in on some tides, which low tides, and then erode slightly under spring tides. So, and that's all in a paper. That's quite interesting. It's always a real area of concern when you're designing one of these schemes. What will be the impacts on the wider environment? So we deliberately spent quite some time monitoring this, so we'd have some lessons for future schemes. A slight detail was we expected the channel to go straight out across the fronting mudflats, but because it occupied this other channel, it sort of stuck in that channel and deepened that channel. There was some early signs of erosion across this fronting area, but that thus far hasn't developed into a secondary channel. These are changes in the breach location. So these are the flood embankments. This is sort of roughly from left to right across this photograph. These are the former flood embankments, standing a couple of meters tall. This is roughly around mean high water springs is the level of the majority of the site. So that was the former fields. And then we've cut an initial channel here. It'll be a bit clearer on the next slide, but basically the channel was this red line. That was what it started off doing. And although we've predicted the stable channel size, that's not always the size of channel that's excavated, because excavation costs money, and excavating very deep channels costs more money, and does bring with it some health and safety concerns of deep excavations in soft sediments. So the channel that was constructed was shallower than what we thought the final end form would be, and then it erodes over time, and we can see what's the scale here. That's about 1 meter. So it's eroding by 3 or 4 meters over time. So rapid erosion as you see this sort of channel opening up. And if you could just see in the background here, where my cursor is, there's a little bit of a waterfall, and that was very interesting because I'll come back to it in a minute. Here's some predictions of stable breach size from a regime approach versus the green line is the deepest channel we observed. So what we find is this central slot has deepened beneath what we thought it would, driven by the large tidal range. So the channel had the chance of eroding in its width or its depth, and it's sort of gone for depth, driven by that large tidal range, and that's quite hard to predict the exact dimensions of that channel. A few more images of the site. So if we start here looking at the main channel into the site, and then move around some of these other sites. If we look at the main channel, here we're looking into the site just after construction. It's a very shallow channel. It's 1 or 2 possibly meters deep. It's a flat bottom, and then after several years it's eroded. The flows have eroded and created this V-shaped channel. If we look at what happens when that main channel erodes and it cuts back into the site, I'll show you some more images in a minute, but it leaves these hanging creeks at the side where they come into the main channel, and then they start to do the same process and erode back. Early days in the site, we had some low-lying areas that site managers particularly like, because they encourage bird usage. They fill with water. The water tends to drain out at low water, and that creates some extra channel formation through our site. And then these lagoons at the back of the site, which are shown here in the green, over time, basically, because they're large areas of water at the back of the site where flow speeds are low, they tend to fill with sediment-laden waters. Sediment gets deposited, and they fill with sediment. So they filled up by at least, what's this? This is about a metre or so of sediment in a couple of years. So they're areas of high deposition. They're still valuable for temporary sort of habitat for birds, but they don't sort of remain that way indefinitely. A little bit of information on, I mentioned that step feature in the main channel. Let's have a look at this. Basically, the channel forms this waterfall. So this is the step feature. It's a bit of a messy plot, but this is a longitudinal profile of the channel over time. And soon after opening, there's a big waterfall as water's flowing out through our shallow bottomed channel, and then it's sort of deepening further seawards. And then over time, we have a cutback of the step feature, and as it cuts back, the step feature tends to get smaller and the bed levels get shallower, and so eventually you get a smooth bed form longitudinal profile into the site. And here was an attempt back in 2018 to sort of map the speed of which that was going, and it was more rapidly at first, and then it began to slow off, but it was still going in 2018. And I have not been back to the site to see it for a while, but I have seen this bit, and now the step features migrated out of sight into the site and presumably continued to get smaller. So that's quite interesting. Impacts on the wider estuary. There were various concerns because of this is a big change to the estuary, concerns in the planning stages. So the things we were most concerned about, changing position of the channel or the formation of banks, because the estuary's used for navigation to the port of Dunbar. And there were some concerns down here, Burnham-on-Sea, that maybe there could be a deposition of mud, or there could be undermining of the defences. And basically, the monitoring we did over 4 years showed that none of those things occurred. The estuary channel is very dynamic, but there were no consistent changes due to our project making it worse in any particular way. Conscious of time, so I'll sort of move on to some lessons. When in the design stage, we used some 3-dimensional design, and then that information was fed to GPS control plant. At the time, that was quite new, so the bulldozers and excavators know exactly which elevations to create. That's now the norm, but this was over 10 years ago. There's a paper on estuary water level impacts. That was a key bit of learning that came out of this project. There's another paper on the speed of evolution of the breach, which again is very interesting if you're trying to design these schemes. I started a PhD project with the University of Southampton after the project to help improve the design of creek systems. So again, that's sort of some new findings that have come out of this particular project. And then more recently, I've been working with Manchester Metropolitan University to measure the carbon that's stored in the site. And this little graph is showing us that the amount of carbon trapped in the Steart Marshes realignment is up to 35 times higher than some of the reported values you find in the literature for natural marshes. And that's because the site's rapidly filling with sediment once it's opened. But what that led us to was investigating other habitat restoration sites to see if they also trapped a lot of carbon, and they trap a reasonable amount. They don't hit Steart levels. Ask me at the end if you're interested. I guess wrap up with some conclusions. project's a real success. Shortly after it was opened in the following years, it won lots of awards from the Institution of Engineers, from the Chartered Institute of Ecology and Environmental Management, from the Environment Agency, from others. That's really good. Its project is viewed as a huge success and is popular with locals. And what the site managers have been particularly good at doing, WWT, is keeping the project in the media limelight. Here's something that was during COVID times that emphasising the health benefits of salt marshes. Here's something more recently when COP was going on in Scotland. There was something about blue carbon, and this is the site manager promoting some of the work that we've been doing and they've been doing to draw attention to the carbon sequestration ability of salt marshes. So they've done a great job of keeping the site in the media limelight. And that is it. Thank you. Happy to take any sort of questions that you have.
Super, thanks, Nigel. That was really interesting. So if people have got questions, can they raise their hands and then you can come turn your mic off and ask a question. Okay, so first one then, we have a question from Chris Proctor. Chris, you need to come off mute.
Fair point. We're 5 years in and I still forget to mute myself. Yeah, fantastic talk, Nigel. Really, really interesting. Out of interest, obviously at the start you were talking about the potential impact of flood risk and the modelling and the approach to the breaches. Did you also have to do any kind of sensitivity analysis about the over time, obviously the deposition of the salt marshes and what that would do if it's obviously it's going to reduce capacity and things, or did anything like that have to be done?
We did do some scenarios. It's a while ago now. I don't think we did any analysis of to allow for the accretion. I guess we did put sea level rise on, and that makes, as you'd imagine, things worse. It sort of increases water levels. We didn't artificially sort of warp up the site and feed that revised bathymetry back into the model. I guess we could have, but it would have improved the answer. Basically, the increase in flood risk that comes about due to the site increasing water levels arises because of the water that's flowing into the site and some of it's scooting on past the site. Mm-hmm. So if you then make it so there's less water goes into the site because the site's full of mud instead of just water, then you sort of reduce that impact. So I guess we've appraised a worst case sort of scenario, if you like. Yeah, and then the other thing that you could consider is, because we're running our model and we're not altering the elevation of the site, we're not altering the elevation of the estuary either. So you say that the site, the model shows that if you left everything alone and just raised water levels, then it increases flow speeds. But those increased flow speeds have the capacity to erode the estuary. So if you were doing this in a sort of researchy environment, you could then say, okay, well, maybe now I'll deepen my estuary and I'll rerun my hydrodynamic model. We didn't do that, but you could have all manner of enjoyment from doing that.
Yeah, speak for yourself. Thanks, Nigel. Next one, so Adam Key, you're the next one.
Hello. A very good talk. I really enjoyed it. Fascinating about salt marshes and their morphology. I've got two questions. One sort of a geomorphology question, and the second one is about the design process. My first question: when the embankment was breached, and also when cutbacks happening into the mud flats, is it cut back in the true sense of the word? How does it actually take place? Is it cut back, or do you sort of see vertical incision taking place sort of all at once as the flow across the mud flats takes place, the tidal flow, or how does it work? How do the channels form? Do you see the creeks sort of form and the cutback take place? How does it work?
question. The most obvious thing is that the site starts off with very shallow channels, and those channels go out so through the fronting intertidal. And when the site is opened, the biggest changes that you see are at the seaward end of the channel system, and that rapidly forms a step, at this waterfall feature. If you can still see my slides, let's have a look. Let's scoot on up. Then, yeah, this one's a good one. So you can see that this is in March, after the site's been open for, what's that, about 6 months. And you see this waterfall feature here. That then cuts back into the site. So maybe there's some minor lowering of bed levels more uniformly, but the biggest feature is this step forming. And if you look on this longitudinal profile, this is a seaward extent, and these are different time periods. So the yellow, for example, is an early time period, and you have this flat-bottomed creek that we've constructed, and then woof, it goes over a waterfall as all of this is eroding rapidly there. And then you go back a bit later, and that waterfall is eroded back into the site, and you've got this blue line, and it's slightly, bed levels are slightly elevated. So that's happening. So it really is cut back.
Right, it really is cut back. Okay, that's very interesting. And secondly, my second question was, you obviously, do you consider yourself a geomorphologist, or do you consider yourself an engineering geomorphologist or a geomorphology designer? And how do you work with sort of landscape architects in developing the project?
No, good question. I think I generally say I'm a coastal geomorphologist. Sometimes I say I'm a coastal scientist. Depends who I'm talking to. Right. So yeah, I generally coastal geomorphologist. I don't use engineering geomorphologist, though I'm a fellow of the Institution of Civil Engineers. Perhaps I should. Yeah, I think of myself as a geomorphologist. Do we work with landscape architects? Yes, in the design and assessment process. Often we have to do landscape assessments. Some of the other projects we do work with sort of we have a sort of urban planning team, so we do get involved with those sometimes. I mean, that's quite interesting because those folk tend to be quite visionary,
yeah,
but don't appreciate some of the technicalities, that some things won't work because water flows in a certain way, for example. So that can be sort of quite interesting. They're very visionary. They do beautiful diagrams of things, and I guess you, as the technical person, you need to sort of say, well, yeah, that could potentially work, and we'll do some detailed design on that. Or no, that just won't work. You can't be drawing that on a plan type diagram.
Yeah,
so it can be interesting.
We'll move on to some other questions, as there's a few other people with hands up and we've got limited time. So thanks, Adam. Next question was from Nick Everett.
Thanks for the talk, Nigel. Quick geomorph question, if you could possibly go back to the slide showing the changes in elevation. I think I noticed quite a lot of accretion outside the site along the Parrot. And I wondered if whether you got a handle on to what extent that was part of an ongoing trend, which might have been in place before the site was opened, or to what extent it was affected by the operation of the site.
Yeah, no, good question. I'm trying to find that one. So, yeah, no, it's a good question. And the honest answer is I don't really know. I've done some more recent work for the Environment Agency looking at changes in the Parrot. And there is, thinking there is a tendency for a net increase in salt marsh. It's not a perfect analysis we've done of it, but I think there is a tendency for increase in salt marsh. The bit that I don't know is whether that's matched by an increase in bed elevations below, sort of low water, because we don't have the data for that. So if you were forcing me to give an answer, I think yes, the parrot is accretionary still. There isn't really a good data set to examine whether that, it's been infilling over the last 100 years and whether there's been any change in that behavior. But I think the general pattern is, from the other study I've done, accretion of salt marsh. Certainly there's a lot of suspended sediment in the area that you can see being deposited. Don't have a feel for what's happening beneath the water because you don't have the data. I think the other thing to mention with some of these changes can be seasonal as well, that you see accretion on the upper mudflats in the summer and erosion in the winter. You do see that. And as always, it's LiDAR. It ought to screen out vegetation, but does it? Much discussion could be had over a beer about that. But I think it's fairly indicative of sediment deposition over most of these areas.
Thank you. Thanks, Nick. So the next question from Will Manning.
Yeah, thanks. Hi, Nigel. That was excellent.
Hey, Will.
Good to see you. Been a little while, but quite a specific question, this one. But the paper that came out of the Southampton PhD with Clementine and looking at the geomorphological evolution of, was it 10 realignment sites around the country, wasn't it, compared to the natural? I've been really interested in that and spoken to quite a few people around how we use that to track the behaviour and success of the schemes that the Habitat Compensation and Restoration Programme creates for compensation. And I was wondering, from that PhD, so I gather Clementine's gone back to France, but do you have kind of the spatial analysis and code that came out of that? And is it almost in a ready to go space that if we get new LiDAR data sets and if we've got the area of interest polygons, we can kind of rerun that code repeatedly? Is that kind of in place, or is it like a one and done study?
Well, it's a beautiful question for a consulting engineer, Will. It's Jacobs has a tool that we've based on that we can analyze creek networks in things, because Clementine's tool was experimental. It required a lot of fiddling, so we've sort of right, yeah. So we've sort of worked on that quite a bit, so that to develop a tool that we have that can help us design creek systems. So it's a better way of spotting what's developed, but also, I mean, that's useful because we want to design creek systems that are natural. So we have got that. We can give us a call after it.
Yeah, I will, please.
Sounds like this is an offline discussion you guys should have.
Yeah, perfect.
Look at that. I didn't think it would be a money-making venture, but possibly it is.
I'm not saying it is, Nigel.
No, I know. I'm joking with you. But what's interesting from Clementine's work was that if you don't create creek systems, you're like, managed realignment is likely not to have a fully functional or fully developed creek system. By and large, most managed realignments have less creeks than a natural marsh, and that there are a couple of reasons for that. So it is good practice to construct some.
Yeah, no, it's good. I'll give you a call. Thank you.
Thank you. Right, last question at the moment. Colin Leopard.
Hi, Nigel. Really inspiring stuff. Sorry, I know you did briefly mention it. I didn't know if you got time to expand a little bit on why the breach was from the River Parrett side and you didn't come through the Bristol Channel. You mentioned a bridge. I didn't know, was it the costs or the logistics? What was I'm wondering what the reason was, because obviously Bristol Port Company looks like they are going to have to come in from that side, and there's a bit of debate going on that. So I was interested on why the decision was made on this one.
So there were a couple. I mean, we pop the slide back up. There's a road to a village, and so we would have needed to maintain that access, and we need to sort of perhaps got an idea of the scale of opening that we've currently got. So we needed about a 200-meter width opening. So that's a 200-meter bridge. That's expensive. 200 meters of tidal causeway is less expensive, although I doubt many people would be pleased if you decide to make their road tidal and stop them getting out whenever they want and stop emergency services. And I think I'm not sure of the long-term maintenance costs of a tidal road. And the other, well, there was a couple of other factors as well. I mean, if we did consider a scheme connecting with the Port of Bristol project, and we sort of thought, well, that's okay, but notwithstanding the road access, it could be okay, could be nice. But the thing is, the Environment Agency would then be dependent on the Port of Bristol project going ahead before they could implement their own. And as it happened, you know, we've waited 10 years and it still isn't built because they didn't need to build it. So it was a good sort of risk mitigation not to be reliant on that. We did consider an opening further north. The road and the bridge are the key things, and a slight thing, geomorphological consideration, that probably this was a spit with a marsh system at the back originally. The lowest areas are near the estuary. This has got some old, it's quite interesting actually, it's mud flats, a little bit of salt marsh, then there's some gravel ridges at the top from a former higher energy setting, and then on top of those there's sand dunes. So you get the feeling that this is a spit really with a marsh that should be at the back of it. So just for multiple reasons really seemed the most obvious thing, link from the Parrot. And it's, you've got to consider the effects on longshore transport if you're chopping holes in former spits.
Excellent. No, really helpful. Thank you very much.
Well, thank you very much to all the questions, and thank you, Nigel, for a really interesting talk. Just a reminder, it will be placed online on the BSG's YouTube site in time, in a couple of days, by the time we've got the recording and cut the chat from the front. And then just a reminder, next Wednesday we have a talk on landslides and geosystem services. So thanks, Nigel. Thanks all. We'll see you in due course. Thank you. Bye.